Welcome. In this video, we are going to look at one of the interesting questions under projectile motion. We are going to look at this question which says, the diagram shows a basketball player who's 2 meters tall shooting a ball at an angle of 60 degrees with the initial velocity of 5 meters per second. So this is the question. Then we have been given this diagram where this is the man, the football, the basketballer, projecting the ball at 60 degrees while giving it the initial velocity of 5 meters per second in trying to score. Yes, so that the ball can go through this hoop or can go through this basket. Now, this question demands us to find one, we need to write the expressions for horizontal and vertical components of the velocity. Then two, if it takes 3 seconds to reach the basket, find the horizontal and vertical components. C, calculate the distance between the player and the basket. Then what is the maximum height of the ball? So this is the question that we're going to consider in this video, and we're going to proceed as follows. For something that is projected at an angle and going in this direction, or when an object is thrown, like for example, if I happen to throw this marker, I project it at an angle, then I throw it. Then the path that it takes is this one. And this path that is taken by a projectile is called a trajectory path. Trajectory. Then the distance that it covers from this point where the man is standing until this point where there is this basket, this distance, the horizontal distance, is what we call the range. Now, the height that the ball is going to reach is, if we are considering from the ground, so from this point to this point. So it is from this point until getting to this point. So this is the maximum height. Now, from this point, we can proceed as follows. So let us proceed. Let me erase this part. So in trying to come up with expressions for vertical and horizontal components, we have a scenario such as this one. So it is this one. We have theta here. Then we have this one, which is the V naught. So we have this one. So this one was projected at this angle and coming like that one. So the scenario that we had, the man standing here. Okay, we have the man the ball is here. Then the basket is somewhere here. Now the angle at which this was projected was 60 degrees. So from this, let me just write it properly so that we can resolve nicely. This is the angle theta. Then this is the initial velocity. So now, when we want to resolve this in the horizontal, so we have the horizontal component in this way, in this line, then the vertical one is in this direction. So the horizontal, this is x, so we call horizontal as, let us call this as Vx, and let us call this as Vy. So we can resolve from this. Okay, so this is Vy, and also this is Vy. If we want, we can do this. So this one and this one are also equal. So for this one, we know from Zokatoa that sine theta is equal to opposite. In this one, we have Vy, then over the hypotenuse is this one, Vo. So this one we have Vy is equal to Vo sine theta. So this is the vertical vertical component of the velocity, the initial velocity. Now, again, we know that cos theta, the cosine of theta is equal to adjacent, which is Vx over hypotenuse, which is this one, Vo. So that this one, we make it the subject, we make Vx, the subject we're going to have Vo cos theta. So this is how we resolve. So from this, we have answered the first part, which is write down the expressions for horizontal and vertical components. So for horizontal one, that's the A1 Vx is equal to Vo cos theta. Then 2 Vy, the vertical component, which is equal to Vo sine theta. So we are done for this. So this is question A. Question B. If it takes 3 seconds to reach the maximum or to reach the basket, find the horizontal and vertical components. So this one, we just need to plug in the values in this one. So B, we know that Vx, so this, let us call this B1, is equal to Vo cos theta. So here what we have is 5 meters per second cosine of 60 degrees. Cosine of 60, cosine of 60 degrees, this is just 0.5, and 0.5 times 5, well, 2.5 meters per second. Then B2, which is the vertical, we have Vy is equal to Vo sine theta. So plugging in 5, what we're going to have is 4.33 meters per second. So from this, we can proceed now to the third part, which is to calculate the distance between the player and the basket. And that is simply the range. The player is here, then the basket here. So this distance is what we call the range. So range is found by, this is just Vxt, which is Vx, we have Vo cos theta, then T. We plug in the values, we have 5 times cos 60 times 3. So here, what we're going to get is 2.5 times 3, which will give us 7.5 meters. Okay, as the range. Now, from this, we are told to find the maximum height. We're going to find the maximum height. So we're going to proceed. When an object is thrown up, when it reaches the maximum height, it will stop moving, then start coming back. So we have a scenario where it goes like this. Then when it reaches the maximum height, it will start falling. So this one, there is a point at which it will stop, then start coming. So at a point where it reaches this maximum height, the velocity, the final velocity becomes 0. So from this, we're going to proceed to find the maximum height here. So at h max, v is equal to 0. So we have v squared is equal to u squared plus 2ax. We know this equation so well. So since it is in y, we have v squared, vy squared plus 2gs, 2ax. This one a, we can replace it by negative g. Then this one, we replace it by h. So this one, since it is 0, we can say 0 is equal to Vy, we found it to be Vo sine theta. So this one squared minus 2gh. So this one, it can come this way, and we're going to have 2gh is equal to Vo squared sine squared theta. So we divide by 2g, also here by 2g. So here we're going to have h is equal to VO with a 5 squared, then sine squared theta, which is simply the same as sine 60 squared over 2 times 9.8. This one is going to give us 0.9 meters. But H max, the maximum height at which the ball will reach, will be the height of the man plus the height it will reach after throwing, of which this is the one. So H max is equal to 2 meters, which is the height of the man, plus 0.9 meters. So meters. What we're going to have is 2.9 meters as the maximum height the ball will reach. Thank you so much, President.